Okay, so this is going to be the common notions and axioms that are the foundation of Euclidean plane geometry. So on your guided notes, on 1.1, right here, we're going to start with the common notions. So take notes here. If the video is going too fast, feel free to pause it so you can catch up. So the common notions. Number 1, things equal to the same thing are equal to each other. That's also known as the transitive property. If two things are equal to the same thing, then they're also equal to each other. If equals are added to equals, the sums are equal. That is the addition postulate. 3. If equals are subtracted from equals, the differences are also equal. That is also known as the subtraction postulate. And number 4, the whole is greater than any of its parts. Now some of you might say that's pretty obvious, the whole is greater than any of its parts, but that's the whole thing with these common notions. They are somewhat obvious. This is also known as the partition postulate. And then lastly, number 5, a geometric figure can be moved without change of size or shape. We're going to talk a lot about this when we talk about geometric transformations. This is a rigid transformation, so that's all Euclid was saying, is you can take a shape, move it anywhere in the plane without changing its size and shape. So those are the common notions. Now we want to talk about the axioms. So on page 2, over here, we're going to talk about axioms. An axiom is a proposition that is assumed without proof for the sake of studying the consequences that follow from it. That's also known as a postulate. So that's really the foundation of geometry, or any geometry for that matter. So Euclidean geometry has these 5 axioms. Other geometries have different axioms. And so what we're going to do is these are going to be the rules that we set up, and then we're going to use those to prove our theorems later on. So what's Axiom 1? 2 points are on one and only one line. You've all heard that, I'm sure, before, that 2 points form a line. So what's Axiom 2? Any segment can be extended by a segment equal to a given segment. So that's all that's saying is you can take one line segment and extend it any distance. It's not saying you're going to extend it the same distance. You're basically going to extend it any distance you want. So Axiom 3. A circle can be drawn with any given center and radius. Euclid used a straight edge and compass to do most of his work, and the compass is what we're going to use very soon when we start our geometric constructions. So that's all that he's saying, is you can draw any circle you want with any given center and radius. Axiom 4, also fairly obvious, all right angles are equal, all right angles are 90 degrees, but this is actually very important for Euclidean geometry. Other geometries actually assume different things, but for Euclidean geometry we want to assume all right angles are equal. And number 5, and I've circled and starred this one because this one is actually quite wordy. So all the other ones are pretty simple, right? But let's take a look at what number 5 says. If 2 lines are cut by a transversal in such a way that the sum of the 2 interior angles on one side of the transversal is less than 180 degrees, the lines will meet on that side of the transversal. Now what in the world does that mean? Let's take a look at these 2 lines. Let's add a transversal. So the 2 interior angles on one side, these 2 purple ones, right here. If those two angles, if their sum is less than 180 degrees, then that means that the two lines are going to meet somewhere over here. That's all that Euclid's saying. So if they're less than 180 degrees, the lines are going to meet somewhere out here. They don't have to intersect right here, but they will intersect at some point. So that's all Euclid is basically saying on the fifth axiom. So that one was a little complicated, and actually that was one that Euclid himself struggled with. But that's the basic concept here, what we're going to study in Euclidean plane geometry. We're going to use these rules to prove many, many theorems, and you're going to use these when you actually construct your own geometric proofs. So please make sure you have all of these written down, and if you need to rewind the video and look at it again, feel free. And if you have any questions, please let me know. You can ask me in class or send me an email.